I'm going to talk about the IRIS for Health FHIR repository and how you can customize that. My name is Theo Stolker. I'm a senior sales engineer at InterSystems in the Netherlands. Started last year, so I've been with the company for just about a year. And I've been working with 807 FHIR since roughly 2015. So really the first version, we did even a project with DSTU1. InterSystems IRIS for Health is a world-class FHIR repository. So why would you need to customize it? Well, I guess in most cases that's probably not needed, but if you need to, it's easy. That's the message I want to talk about today. Some use cases, why you might want to customize. You may want to add additional constraints. You may want to do some pre-processing or post-processing of your resources. And you maybe want to customize your capability statement to exactly reflect the capabilities you want to expose to the client. And there's more reasons. It may be related to authentication or authorization. So there's plenty of reasons, and we're just going to talk about a subset of these. I'm going to use a scenario from a customer project, a Dutch project named Koppeltaal, where we're using 807 FHIR R4 and a fairly limited set of resources, which are listed here. The customization is done through object script. Of course, you might use Python as well. Some part are actually showing Python code. And I'm using the plugins in Visual Code to show the code and make the changes. And I'll be using Postman for submitting requests to the FHIR API. If you're interested in looking at the code, it's available. The repository link is in the presentation. Feel free to go there and check it out. If you look at the options for customization, there's actually two different ways. One would be to use the interoperability production level, where you create an interop server and an interop operation and build your process between it that deals with each request and handles it. I'm not going to use that method. I think the production will add a little bit more overhead, so we're going to directly customize the so-called FHIR interaction strategy classes. Before we go there, I want to talk briefly about the storage model used by default in the IRIS for Health FHIR repository. It uses 4 types of tables. One to store the current resource versions, the r.rsrc table. One to store the older versions, the history. One table per resource type that stores the search columns. And there's also a common one table that stores the search columns that are common across all resources. Why do I talk about that? Because we're going to need this bit of information later on. I'm going to customize these 4 classes. And I recommend you to always do that. You may not have an immediate need, for example, to change the resource superclass, but it's good to start doing that so that later, when you need it, you can do it. These 5 classes I'm going to show in the next couple of slides. So the repo manager class, which links to the interaction strategy, which links to the other 3, where the interactions class is by far the most important when it comes to customization. That's where you do the majority of the work. I hope this is readable. What I created is a minimal set of classes where I just did the bare minimum that you need. And in the actual code that's being shared, this is available, but there's also a version with much more changes. You have to choose your strategy key, which in my case is minimal. By default, it's JSON, And I have seen many cases where people used a project-specific prefix, for example, plus JSON. But you can freely choose this. And then you refer to the class name of the interaction strategy class. As you can see here, I'm using the hs.local.FHIR server package, which is by default available in all namespaces. That's like a trick to avoid having to create package mappings, having your code by default available in all namespaces. In the interaction strategy, the next class, you'll see the strategy key is repeated. And then there's the references, the names of the other 3 classes. At the bottom, you see the resource superclass and resource version superclass. And it's just extending the base ones, nothing added there right now. The top one is just a copy from the previous page. And then the last one, the interactions class, like I said, that's where we're going to spend most of the time making our customizations. It, apart from extending the base interactions class, it also has a strategy property, which is an instance of the strategy class. All right, I'm going to switch to my local environment to just see it. Let me refresh, make sure that I have a current session. So you go to Health, to FHIR configuration, server configuration, and I'm going to add an endpoint now. First, you pick the version, and it will automatically propose a base URL that is going to work. In this case, I want to pick an additional package. We're going to use that later in the samples. And here is the really important part. This is why you have to create or subclass your classes before you create your repository. You can only do this at time of creation, not afterwards. So the top one is the default JSON interaction strategy. This is the minimal one that I was creating. And this is where the actual project builds upon. So in this case, I would suggest I pick that one. The other options here, I usually leave as is and say add. Now, this will take a while, it will create one, but we can continue working with the already existing one, which has the same changes. And when I open it, I want to point out a specific, 2 specific options here at the end. The first one, allow unauthenticated access, which you're of course not going to use in a production environment or any environment with live data. But for a development environment, it's actually very convenient. So that's what I'm using. And this is really important when you're debugging, to select the new service instance. This will automatically create a new instance of your code for each request, meaning that you make a change, you FHIR request, and it immediately works with your latest code. All right, back to the PowerPoint. We're going to talk about in the remainder of the session. I want to do some pre-processing of requests, some post-processing, and after we talk about how you can debug the inner workings of the FHIR server, we're going to look at referential integrity. A little sidestep. FHIR defines these interactions. Maybe you all know this. I just want to point out that basically for each of the interactions specified here, like read and update, you'll find methods in the interactions class. There's a few exceptions for create, the create type level interaction. There's actually an add method. And there's a couple of things that are convenient to know, like the read method is also used for vread, for the versioned read, and it's used also for each resource that is part of that's inserted into a search bundle. So you can actually customize more than just the read by changing your read method. So the first use case. By default, the IRIS for Health file repository uses an incrementing integer, right? First resource gets ID 1 and so on, 2, 3. In some cases, people don't like those predictable numbers, but want to have something that is more like a GUID. And so that's what we wanted to do in this project. And in the add method, you can just populate the P resource ID to assign parameter with anything that is unique. In this case, we're picking a new GUID and turn it to lowercase. Then next, you have to call the superclass to actually do the work through # super. I'm not going to demonstrate it right away. That will be done after we have looked at the second part, which is identifiers and uniqueness. In this project, we wanted to make sure that you could not insert the same patient, a patient like real-world patients with the same identifiers twice. Of course, you could request your clients to take care of that, but we felt it was much more logical to do it inside the FHIR repository. So whenever we receive an add or somebody updates a resource, we're going to, and there are identifiers present, then we're going to check that those are unique. Which, in this bit of code, you'll see we loop through the identifiers. Let's start with the first line. This get table for resource type, this is one of the helpful methods that is available only in the interactions class that gives you the search table for a specific resource type. And in that search table, we can then look for the identifiers being present. We have one exception. Of course, when you update, you don't want to block the update because the current version of the resource has the same identifier. So we're going to check whether other resources have the same identifier. And in that case, we throw an exception. Okay, let's try this in Postman. So if I want to create a new patient, you can see the logic is already there. This identifier is already being used. And when I change it, this is a unique identifier, so it accepts it. This is, of course, not a great example in terms of like a real-world identifier. I just picked something simple. But your customer might have very specific requirements in terms of which identifiers are going to be used. And like I pointed out before, each identifier we're going to check for uniqueness. Something I would point out, something I realized later today, that I'm using the prefer header to actually return the resource, return this representation. That's not a default. If you leave this out, if I do it now, I'll just get the same error again because this resource already exists, right? But then I would just get the normal headers, the location header and the e-tag header, and not the whole resource. All right. Let me go back to the. Let me just read this patient. And we're going to talk more about this. So that was the part where we're going to do the pre-processing. And let's move on to the post-processing part. 4 references. I assume when you're familiar with FHIR, you've seen the use of the reference property of the reference, kind of pointing to the thing you refer to. The display value is also very useful, particularly if you retrieve FHIR resources. Excuse me. It can give you additional information about the resource being referenced. By using the built-in reference visitor, you can easily enhance each reference. The reference visitor calls a callback method for each available reference in a resource. So, and there we call, well, our own logic. What I did to make that work is basically agree on a specific package, like a class path, where we store the a resource type specific class that has a getDisplayForReference method. Of course, you can not define it. Then there will be no extending of the no display being added for that type. We talk about the generate text later. Then in this this code, you'll see how we call the reference visitor by, well, passing the schema, which is like R4 in this case. We indicate on what instance it works and what the name of the class method is. Sorry, what the name of the method is in this case, at DisplayForReference. And then in the reference, we're again looking up the resource class, checking if that exists. Actually, this looks to the general table, although it seems to require the resource type. It looks at the general table for the resource. It checks whether it exists, and then retrieves through by calling the resource type specific version of the getDisplayReference and setting the display value based on that. We're going to also look at the result later, but let's move on to the resource text. Resource text is very similar to what you might be familiar with in 807 version 3 CDA, where there is also a, well, text version of the resource for cases where you, well, want to be able to use it as a human. And a similar concept is present in the FHIR text property. And what you want to do is populate the text property automatically if it's not there, using the generate text method. I used a really simple example here for the organization resource, where we pass in the text will be populated with organization named and then the name of the organization. But there is an example. Oh well, let's look at this code first. Basically, this is simpler than the adding the display for the references, because you only deal with the current resource. But of course, I mean, you need to do some specific work. The text property is, the diff of the text property is an XHTML. And so you need to provide a little bit of XML structure, HTML structure, I should say. And then the text might have further HTML. Thanks to Tani Frankel, he provided a better method to do this, which is using Python and Jinja 2 templating. This way you can create, well, you do less coding, and you have more freedom in terms of how you populate your text. There's still a bit of coding needed to get the right properties before you render your template. Someone pointed out when I was showing this that you might also populate the text while you store it, right? The resource isn't going to change, so why would you generate the text every time, over and over again, when you retrieve it? Well, the assumption I had is that maybe you want to change your template over time. And in that case, you have to do it at the time of retrieval. Even though your resource doesn't change, your text resource might actually change. So that's the advantage. Of course, it comes with a cost. It will require additional, like, CPU cycles. Last, I had some fun with this. A question for the audience: if you use the default FHIR IRIS for Health FHIR repository and you insert an object, where will you find the ID property? Nobody? It will be at the end. That's the default behavior of the JSON like implementation. It always inserts properties at the end, which is a little odd if you think about it from the FHIR specification perspective, which has like a defined schema. Well, in one way, it's perfectly valid because the rule is JSON has no property order. But again, as a human, you may be confused, having to scroll down all the way to the end of your resource before you see that ID. And that may be the same for extensions being added, etc., etc. So what I did is try to like create the same order as the specification had. I first built, thanks to some code from Julius Cava, I built a simple, like a shallow method where I only ordered the resource type, ID, meta, text, and extension properties. Later on, I figured out that I could also convert it to XML, which uses schema sequences, which are ordered, and then convert it back to JSON. And in that case, I would have a deep ordering. It takes more cycles, right? It's more expensive, but it works. So, pretty cool. Now, when I did that side step and showed you the prefer return is representation, so the create and update method allows you to see the resource as it has been modified by the server, right? So the text is being added. We have enriched the references. And if you want to do that, we need to change the instance of the object that you passed in. That was a little more, that was really a challenge. I tried to remove the properties and reinsert them, and found out that I had ended up with a completely reversed set of properties. So the ID was again at the end, or resource type was even at the far end, right? And then it was kind of reversed. This has to do with the fact that when you use the dynamic object class and when you insert a property and you have removed properties before, it will pick the last available slot. It's kind of funny behavior I found, but it was, once I figured this one out, it was relatively straightforward to first reverse again all the property names and reinsert them back. And then I could also change a current object and reorder the properties. All right, I think it's time to, oh yeah, this is the code I wanted to show. At the top here, you'll see the shallow version, not all the code. But, I mean, if you want to look at all the code, I'm afraid I'm going to run out of time. The next one, although it is more expensive, the code is actually really simple. There's built-in methods that use the schema to transform your object to XML, and then back to JSON, which leaves the object in a perfectly ordered sequence. And this bit is only used from the create and update methods, where we order the object itself. The object being passed in is reordered. All right, so this is what I ended up. And we can look at this also in the actual class. Let's switch there. So this is the interactions class. You see a bit more code now than we had in the minimal version, where the add method, there's still one thing we want to talk about later, the validate references, but you see the identifier checking and the post-processing of the resource, where we pass in, if you hover over it, you see the modify original object, parameter being set to 1 in this case. Update has the same logic, and here's the actual code that deals with the post-processing of the resource. Also read does it, by the way. So we're calling the super class first, which returns the resource being retrieved, and based on that we're going to do the same post-processing. All right, I think that's, yeah, let's show it some examples and look at some examples now in Postman again. So if I retrieve that patient, we already did here, code hasn't changed, so you'll see that we should see the text here. Let me try again. What happened? I see no text. All right, something is broken. Let's go back to the code. Here's actually where the debugging may come in handy. Let me switch briefly to the slide that talks about it. All the built-in code of the IRIS for Health FHIR repository uses this fslog global to log its behavior, so you can kind of follow what's happening. Of course, you can go to the global viewer and look at that code, or look at the global, and you need to scroll to the far end to find the latest one. And of course, I have to admit, I'm not like a super power user when it comes to using globals. In this case, again, somebody contributed a nice viewer for it. It's also in the repository, so you can just refresh this page and you'll see the latest at the top. And you'll see here that actually for patient there's an object script error. And okay, I had not expected this. This was supposed to work. I'm not going to try to fix it, but at least kind of the point of the fslog is made here. Maybe you have like a few minutes after the presentation, I can still fix it. I can try some other resources. Let's take the read organization here. Here you see the text being populated, so this one did work. And also here is there, yeah, so this one has an, and this is again authorized. This is what I was expecting. So there's a part of reference. This is a hierarchical organization, so it refers to the top level organization, and the display is being populated. And for some odd reason, I'm referring to an endpoint where it cannot find the text. Well, I guess because I did not create a plugin for endpoint. Indeed, that's not in the list of resources yet. So, I mean, this is kind of the status of the current code. And the only part left, and maybe the most interesting part, is the part where we talk about references, referential integrity. By default, if you insert like an observation, an observation most of the times refers to a patient, right? You can perfectly insert an observation that refers to a non-existing patient. Although technically there's nothing wrong with it, maybe business-wise that may be confusing because later you retrieve that observation and it points to a non-existent patient. So that doesn't make much sense. What I did in this demo will actually be ensuring referential integrity and not only for create and update but also for delete. Also, we're going to look at a few other reference types like logical and conditional references. Again, the structure of the reference element, which has the reference again, but there's also an identifier. And maybe talking it more from the specification perspective, we usually talk about literal references, and most of the times literal relative references, so something like patient/ID. You may use absolute references, so have the whole path to the resource. We're not going to do that in this use case. Something very useful when you're, for example, building a bridge, an HL7 version 2 bridge, is the logical reference, where you use an identifier to refer to another, to a resource. So there is an example here in the screen where you see a reference to a practitioner using this person's NPI. There are cases where the identifier may not point to a unique resource type, and if that type of reference, the reference in that particular case can point to multiple resource types, you have to specify the reference .type. This was added in R4. You kind of make it, well, less ambiguous to specify the type. Another type of reference is the conditional reference, which is, according to the specification, intended to be used in transaction bundles, but it's actually convenient also in other cases. So we have added that support for that as well here. There's even more types of references to just be complete. There's internal references to contained resources, which start with a hash and then the ID of the contained resource. You may see temporary UID references within a bundle. Those are replaced when the resources are processed. And last but not least, and this we're actually going to use in this use case, canonical references, which are referring to a definition resource. In our case, in the subset of resources, we use task points to activity definition to the URL of the activity definition through the instantiates canonical property. For logical and conditional references, we're actually going to populate the reference property. So setting the relative reference to the resource that it refers to. And it kind of follows out later why we do that. Let's go to the code again. There's a utility class here named ref_int helper. Oh, one thing I did not talk about and actually should have spoken about. I told you about this reference visitor. Unfortunately, in the current version of the code, it only visits references where the reference property of the reference is populated. If you receive a logical reference, it's not going to be visited. So I had to subclass the reference visitor to make sure that you could also visit logical references, and also I'm getting confused. What's the term that we just had? The canonical references, right? Were not handled, and that's what done in the custom code here. Let's see, it looks very similar. I'm going to skip the customization code. This is something that I recommend you to look at later if you're interested. But here you see that we now have to do a bit more checking. The reference may be populated, in which case it can be a canonical reference, or it can be a conditional reference. We're going to check all these different types. When it's a conditional reference or it's a logical reference, we're going to check the identifier value and populate the actual resource reference. This is what happens here. It's fairly straightforward. We have the target resource type. We query on identifier. By the way, logical identifiers can use more than just the identifier. We kind of assumed here that it's only going to use the identifier to refer to other resources. Kind of a simplification. And based on that, we could just use the same code for logical and conditional references. When it's found, we populate the, we return the relative reference, and that's being populated in the, as you can see here, in the resource being processed. So far, so good. So now we can actually, when we create a resource and it points to, well, let's just run it first. I now get an error saying that task.owner, well, there is no resource found with this particular references. Or this one. Again, patient/1 doesn't exist, so you can't insert it. And so on. So, I mean, there's lots of checks here that you can do, which is all well, real-life examples. We're doing a bit of additional checking here, making sure that the resource, that all references can be resolved. And let's see, well, so for example, activity definition, same here. It has a reference to an endpoint in an extension. And this one fails on the owner. Let's see. So a whole bunch of different use cases. Also the Postman resource, the Postman tests are available in the repository. Coming back to the last challenge, how to handle the delete. I tried different kinds of solutions here. In one project, I actually built a bit of configuration where I configured a few reverse include paths for each resource type. So we could check a limited set of resources. But that's not a scalable solution. You can easily misconfigure. You want it to work always without the need for configuration. So that's where I came up with the idea to add an extra column to the resource superclass. So that's one table where for each resource, all the references it has are known. Because, I mean, the problem is a little harder, right? Imagine that case where an observation points to a patient. How do you know that you can safely remove that patient without breaking links? Well, you have to query in some way. And by this mechanism where we store the references in an extra column, that was a really simple query. So that additional column is defined as a list of string with an index, and then in the on add to save set on the subclass resource table, we're going to again visit all references, which now really helps because in this case we have always a relative reference, and those we're going to store inside the table. Let me just show you how that looks like. And so here we could use the reference visitor. We are actually able to, we need to reset that list every time when it's, for create it wouldn't be necessary, but for update we need to reset it. And then still find out again what the current list of resource references is. We do that through the add reference, where we do some deduplication. There might be resources where you have two elements pointing to the same resource, and it doesn't help storing that twice. So this class is where I was talking about. This is the this is what you call the resource superclass, and this is where we overwrite it. And then here, hope this is familiar to you. In the Visual Code Editor, you can actually browse the classes in your runtime, and you can find this like hsfhir.x. In this case, well, the number here is the repository instance. You'll find the r.rsrc, which is the class that builds on our local FHIR server storage JSON resource. I needed to recompile this one as well in order for it to work. And if you look here in SQL, let's just go there. Sorry. Okay, yeah, that's something that happens more often. Let's go to a query here. So this one. Oh, that was a bad idea. Just remove the This is the type of query we would execute. So can I safely remove patient / this particular ID? Yes, because no other resource point to it. But what I actually want to show you is this part. And then order it in reverse order. And I want to have all properties. And here you see this resource references table where we store the list of resources each resource refers to. And now we can magically determine whether, so that's in the next slide, by doing the single query we know whether we can safely delete it or not. All right, with that, well, you need to insert that code, of course, in your delete method, like it's done over here. And we're really cutting it short. It's less than 3 minutes left. So I want to change it over for questions.
Sure. So I asked, what version is this in, 23.1?
Yeah, basically consider it 2023.1.
Okay, so the debugging aspect for that global, that _FS, whatever.
That's there. That has been there for ever, basically, I think.
So I have a 2021.1 version. That global would exist?
Yeah, I expect so. Yeah, I think it's
okay.
there.
Is there automatically populated, or I have to add that?
I think
in the
you
catch?
don't need to do any configuration. I'm not aware that you do need to do.
Okay, I'll check that. Thank you.
All right.
I got to turn it on.
Oh, you need to turn it on? For some magic reason in my environment, that happened automatically. I have not made any changes. Yeah, very possible. So that's a useful bit of information. Let's share that in addition to the current slides, how you turn it on. You go ahead, yeah.
The visit all method, does that actually retrieve the resource, or does it just build a list of resources that are in the resource of interest?
Sorry, can you repeat the first part? I couldn't hear that.
Sure, the visit all method, does that just build a list of all the resource references that are in the resource of interest, or does it actually retrieve those referenced resources?
It kind of traverses through all the properties and calls your callback for each reference it finds.
It does a callback, so it does retrieve all of those.
What, you say no? Well, you don't need to retrieve any resources. You have a resource instance, a JSON object, and your reference visitor kind of iterates over all the properties, finding the specific populated references and returns them to you in your callback. Does that make sense?
It does retrieve the referenced resources then?
You don't need to retrieve the referenced resources. That's not what it does. It just gives you the value of the reference. All right?
One more question, if you don't mind.
Sure, go ahead.
The conditional reference, if you post that, like in a transaction or a batch bundle, I think it says if you don't find one existing match, that it's an error. Is there no concept of, if that resource doesn't exist, that a placeholder resource would be created?
No. That wouldn't make a lot of sense, because you cannot replace well, you would have to know the assigned ID, right?
Yeah, that's what Happy does. It actually creates a resource with an identifier of the string that you pass in. Okay. And then if you subsequently retrieve that resource, it can match it.
Okay.
Thank you.
Anyone else?
Any other questions?
So you thought you can use that method to modify the capability statement?
Right. I did not include it in this presentation. As you see, I'm still running out of time. That was part of the original set, but it's
well,
very
maybe
easy.
We can talk about it later.
We can talk about it later, definitely. There's two things I want to repeat. Actually, so I did not talk about the custom search parameters. There's a bunch of links that are useful. This is what I want to remind you of the sessions about FHIR tomorrow. So, yeah, please come to the same room. And this is also something that we were requested to share. InterSystems is looking for some help on developing a tutorial. Please take this 2-minute survey if you want to help out and have an opinion on what might be a good topic. With that, I want to thank you.
Thank you very much.